So let's continue recording this thing. All right, so this is the Docker workshop for UW blockchain hacks. My name is Connor James. You can call me CJ or James or whatever. So a little bit about me, or before we do that, our agenda for today is just a quick introduction about myself, how to work with Docker, why we're using Docker, maybe some of the terminology that we use for Docker. Oops. We're gonna discuss and use Docker in this workshop. So please bear with me if I struggle once in a while I use Docker. We'll also try to use Docker Compose as well, and then we'll see what we can actually do. We're actually gonna have a simple exercise for using Docker. So this is definitely a workshop if you want to learn Docker. Unfortunately, an hour will not be enough to talk about Docker. I mean, Docker is it's big applications, big subject. So if you want to learn the basic of Docker, which I hope you do, because everybody's using containers in their application or at work, especially my company, we've been very big on like Docker. Okay, so so before we start, I just want to talk about like what's the motivation for using Docker. So imagine if we have an application, for example, and let's say this application will have a web server, and then this web server is run on let's say PHP, and then we have some microservices that are, or a microservice for this example that is used for maybe AI or machine learning that is written in Python. And then we have like a database, like using like Postgres, or it can be like a MySQL. Just think about it as a SQL database. And then this application uses pretty much, they integrate together to provide some functionality for a user. They run on a single computer, and they share binaries, libraries, and dependency, and they all run on the same operating system or hardware. So pretty much we're looking into, for example, a computer, maybe your laptop or your MacBook, and you're running the entire application. Seems like a bad idea, but yeah, it is a bad idea. But the, the, the problem with this type of the problem with this type of with the way we're running this application is that if you think about it, what if for some reason we have to maybe update a library? For example, let's say the microservice that we're using is, we wrote it in Python 2.7, and then we decided, hey, we need to do an update to Python 3 point something, right? So you made a change on the library, and there's a chance that you can actually affect some of the applications that are running in your machine. Like for example, maybe Postgres or your web server is relying on that Python 2.17 that you're trying to get rid of or upgrade. Or maybe there's other external dependencies that are actually relying on that library that that is needed to run your application. So we don't have isolation to those applications. We have shared binaries, library dependencies, even operating system or hardware. If we change the operating system and hardware, we don't know how our application is gonna react. So what Docker, or what a lot of the what people or most engineers like thought about, like, hey, why don't we isolate those applications, those services? So part of the solution for that is they decided to make or create containers. So if we look at this example in here, we have our application running in different containers. And the idea for this is that we want our application to have its own resources, meaning operating system libraries, dependencies, binaries. They're all contained in a single instance, so that if we make changes on container B, our container A is not going to get affected. We don't have that dependency issue that can cause problems with our application. And the way Docker does it is that it does an OS virtualization, meaning Docker provides that layer between the operating system to manage all those containers at runtime. Okay. The other approach for this that I didn't discuss is using a virtual machine. There are differences as far as like using containers and virtual machines, but for the sake of this workshop, we're not going to talk about virtual machines. You can think about virtual machines as more like more, I would say, resource intensive. Like it requires more things to go in there just to run your application, but it's still, you can still achieve like isolation for resources. Okay, before I get started with Docker again, we're just gonna talk about some terminology here real quick. So one terminology I want to talk about is Docker host. So Docker host is just a computer, your laptop running Docker so that you can make Docker image or run them as Docker container. This is just essentially like a machine that's maybe running Linux or a virtual machine running Linux. Okay, so and then we have image and container. So normally those two terms are typically or normally confusing for a lot of developers, a lot of engineers. Those terms are normally interchangeably used. The main distinction about an image and a container is that an image is just a snapshot. You can think about it as like, hey, I'm gonna put all the libraries, dependencies, and application in this image, and then that image is what you're gonna be used as a container or run as a container. So the container is a running instance of that image. So you can make as much as containers as you want out of a single image. Okay, that's the main distinction between image and a container. Now, we also have container registry. It is a repo for Docker image, and I don't know why they don't call it image registry, but the term they use for that is a container registry. So if you look into, if you remember GitHub or GitLab, those websites, they host what do you call it? They host our source codes or projects. Container registry hosts our Docker image. So an example would be if I look at, let's say, Docker Hub. So in Docker Hub, you can see a lot of these images being published, and just these images, you can actually use them. You can pull them down later. Maybe try out maybe this Oracle Java 8 or maybe other images that you can use. But this is pretty much like a repositories of all those images. Okay, and then we also have a tag. So, have a recipe to share with us. Hold on, give me a second here.
I just muted him. Okay.
All right, thank you. All right, so our next term here is the tag. So a tag defines what the version or what release of an image are we using. For example, we have an image here called bash shell / alpine -bash, and then the tag for it is latest. So if we look at, for example, like Docker Hub, and let's look for something much more easier to check out. Like, for example, I'm looking at this Ruby registry. So the name of the image is Ruby, and then the tag will be the version, or I would say like it defines like what's gonna be in that image. It's kind of like a way to like do semantic versioning, making sure You're not breaking an image. You're just making sure that this tag called Buster will remain the same snapshot, like the way you built that image. Okay, and then the volume. So when we run our container, typically we throw them away. We don't put anything persistent in a container. Containers are meant to be run, and if they're done running, they get thrown away. So one way to persist data is we use something what we call as volume, and you can pretty much like mount, let's say a device, your hard drive from your computer to that container, so that your container can actually save some data or retrieve some data when it runs. And we'll see that, hopefully we can see that happen here in the next, once we start working with Docker in a little bit. Okay, let's see. All right, so what I'm gonna do here is I'm gonna discuss how you typically work in Docker, and then after this, we're gonna actually jump into the, like, I'm gonna pull in a project later on, and we can start coding. Okay, so Docker, everything in Docker starts on a Docker file. So this Docker file, you can think about it. You can think about it as like a manifest of how Docker is gonna build, how it's gonna build an image. So just to give you an example on how it would look like, let's see. So I have a project in here. It's very simple. So this is I have two services in this repository. There's the full service, and there's the baked DB service. Those are both services. They're just like some dummy server that we can actually use, make some HTTP calls. So if we look at this baked DB server, so this is written in Go, guys. So if you guys got any question, please let me know. I realize that not a lot of students learn Go or any type of programming language other than C++ or Java or Python where they're at school. But this application is it's a web server. It listens at port 8080, and then if you try to talk to that server, or let's just, for the sake of discussion, we're just gonna name this thing as fake DB service. So if somebody makes a GET request on that fake DB service, it will call this, it will invoke this function called return something, and it will notify the client that, hey, the fake DB service is running. So what I'm gonna do is, just to help you guys visualize what it is, I'm gonna run it, okay? So I'm gonna hit go run main.go, and it will say that our fake DB service is running. Then what I can do is I can curl it. I think I remember. So I can curl it. It says that it's listening at localhost 8080 or port 8080 for this case. So we have port 8080 here. Then I click, if I enter this, it should say that the fake DB service is running. So that is the service that we're gonna try to containerize. The Docker file for this is already been made. So this is, before I explain to you guys what each of these line does. What I can tell is that Docker file is pretty much, this tells Docker like, hey, this is the base image that I want you to use, and these are some of the files that I want you to use in order to build my application. So everything in Docker starts on a Docker file. That is the manifest on how Docker is going to build that image. So from a Docker file, where is my presentation? There you go. You can create an image, okay? So you use, in order to make an image, you what do you call that? You execute a command called docker build. So you know what? You know what I'm gonna do is while I'm going to this workflow, we're actually gonna run some of this commands. So Docker build. So if I do, for example, actually, I actually don't want to confuse you guys. So let's just go back to this presentation. I apologize for it. We'll just go over the process later on. Okay. So Docker build will make an image. Okay. Remember that image is not a container. Okay. It's just a snapshot of what the application is going to be. And then out of that image, you can create a container. Now, when you create a container, that container by default is actually not running. You just have a container sitting inside your Docker host, not doing anything. You have to manually start it. And once you have that Docker container started, now it goes to a run state. That Docker container that is now running goes into a network, okay? There is a thing called Docker network. This Docker network is, you can think about it as a network running inside your machine. And one thing about that network is that you can't just access the containers that are running inside that network. You actually have to tell the container before you run it that, hey, when you run, I want you to expose some ports or some ports that I can map to the local host, so that other applications that are running on the same host can talk into that container running in a different network. And we'll later see that happen. Okay. All right. So inside that network, you can also have multiple Docker containers running. And these Docker containers, they can actually like talk to each other, um, whether using DNS or IP addresses. But normally, they can resolve their own addresses, and you can just talk to them based on their names. But typically on that network, you can have multiple containers running. Okay. If you have an image, you can actually push or pull that image to a container registry. So we talked about it, like, you can have a container registry in Docker Hub. They say, hey, I have this image, I want to share it to my friends. I'm going to push that image into a container registry such as Docker Hub, so that maybe your friend or your coworker can actually download that image later so that they can consume and use it. Keep it in mind that there are different types of container registries. There are Docker Hub, there's also Artifactory, you can also use GitLab for container registries. So just keep that in mind. You're not just limited to just using Docker Hub. So once you have image into the container registry, you can actually, so the entire process that we discussed, like the create and the start, you can actually just do Docker run, and it will actually just push, or not push, but pull the image, create that container, and then start it. So Docker run is an equivalent to pull, create, and start. Okay. And then if you have a container running, you can actually go inside of that container and maybe do some stuff. Like maybe you just want to check out the logs. Let's see what's the health of our application is doing. Maybe you just want to go inside that container just to start some other things or add some files. You can actually do that. You can treat it as an application pretty much. Okay. So what we're gonna do now is we're gonna go back to our code here. So I'm gonna close this Docker file here. So we have two services in here. One is, we talk about the fake DB service, which is just a fake database. It just returns that it is running. That's pretty much it. Nothing special. We also have another service in here. It's called the foo service. So it only does like like maybe like 3 things. Actually, let me try to run it so you guys have an idea. So we have the foo service running. So if I do some curl in there, and this is listening at port 8090. So if I do like hello, which is what we define in here, hello, will be just bring like an hello message. And then there's another one called headers, which just prints, it will just print the headers. And then the other one will be called /bake. And what this /bake does is that it will talk to our big TV service. So just to give you guys like a better picture. So we have 2 services in here. We have foo service, right? And then we have let's just put it like this. Okay. We have our big TV service. And then we can have like a client, which is just making requests. Let's say, hey, I want you to, let's just say, what do we have in here? I want to go to /bake. So if we remember, /bake is the endpoint that we use. Let me actually make this thing bigger. I don't want you guys to. All right, there you go, much better. So what /bake does is that it will make foo server go to what do you call that? It will go to bake DB service. So it will just go into that service. And then what big DB service is going to do, if we remember, it will just say that, hey, big DB service is running. So it's actually gonna respond back to it. How do I do that? Okay, that's good. It will respond back to it with, hey, big DB service is running. So that is the response that we get. And then this response actually gets forwarded back to the user, so that we can say that foo service and bake DB service. It's somewhere like what do you call that? There are kind of like they use foo service uses bake DB service. So if we go back to our code base in here, if we do a curl on the pig, we already saw that pig DB service is running. But if we stop pig DB service and we do the same thing again, we'll get something like an empty reply from the server because pig DB service is running. So for this workshop, what we're gonna do is we're gonna try to containerize those services, and we're gonna make them. We're gonna run them both together, and then we're gonna try to talk to foo service and see if our containers are actually running. Okay. So to get started, I want to start on. You see that we already got some errors in there because I'm not handling any errors. Okay. So if we go to foo service, it only has like one source code in here, which is main.go. So what I'm gonna do in here is we're gonna make a Docker file. Remember, Docker file is what we use to what do you call that? To make a Docker image. So I'm gonna make a Docker file here. So the first line of code I'm gonna be writing is it's gonna be a prompt. And if I remember, this application is written in Go. So typically when you make an image, you will always have some sort of like a base image. It's not necessarily that you need a base image. We can have something we call like a scratch, which is like kind of like start from nothing. But for this example, or for this application, we're gonna need like a base image a base image that will have something like Go in it because our application is running in Go. So what I'm gonna do in here is pretend that I don't know what's going on. I'm gonna write from scratch. So hopefully you'll see how I struggle in here. So if I go to Docker Hub here, or actually Docker Hub, I search for Golang. And I see that Golang has a registry. I can go to the tags. And then let's just say I just want to grab one of the image in here, which is 1.14.3. So I'm going to copy that. So now I have a layer here for Go as like the base image. And then what I'm going to do here, I'm going to set the working directory into, maybe let's just call it like app for now. So what this thing does is that when you build the image, by default, this is where the image is going to start. It's going to start on /app, okay? And then I'm going to copy some of my source codes in here. Let's do, in order to build this application, I need this file called go.mod. And I'm going to copy it to the, this is / here implies /app. Okay, keep it in mind. So I'm just gonna do it like this. And then I also want to copy the source code for my poo service. So if I do, let's see, poo service, right? And then I am gonna mount it at poo service just to keep the directory structure. And then what I'm gonna do in here is that once I got the source code in that image, I want to compile it, right? So let's do, actually before I compile, I want to get my dependencies. So the command for that is run. And then run means that you want to run maybe some shell commands or some bash commands or any sort of commands that your image can actually support. So for this image in here, we can just run go mod download. Go mod download is a command that you use to grab dependencies. If you used like Python before, this might be similar to like a pip installer, or if you've used like npm or node package manager, it's similar to what an npm install will be. Okay. And then the next thing I'm gonna do is I'm gonna compile it, which is run go build -o, and then I'm gonna name it as main, and then the source code is in /poo service. Okay. And then once we have compiled, what we can do is we can now run our application. Actually, before we run our application, we need to expose a port, which is 8080. Expose here, what it does, it allows the application to expose a port so that any of those, let me pull my slide here. So any of those containers can actually be accessible. That's what expose means, okay? So let's go back here, expose 8080, and then the command will be, we're just gonna do main, right? All right. So now that we have a Docker file here, we can now build this as a Docker image. Okay. So hopefully, if I don't get any syntax error here, hopefully it works out pretty well. Okay. So the way I do it is that the command is simple. If you have Docker installed, you just do Docker. You give it like you say Docker build. Docker build means build an image, and then -t means that I want to name this image as bake service, for example. So so that will be the name of our image, and then you have to tell Docker, where do I find this Docker file? So let's say this this file, actually this is foo service. This file is in a directory called foo service, right? And then give it a Docker file. And then the last argument here is the context. And we're gonna put this as dot. Dot means that dot defines the context of where Docker should be looking for files or directories. Because if we look at this, let me see. If we look at this directory, just copy that real quick. We have all these directories and files, but our source code resides in the main directory, which is go mod. If we remember that from line 3, and the main that goes in the foo.service, so that if we do, oops, I think I've lost that command. Let me just type it again. So if I, for example, let's just say that for some reason I changed the context into a different directory. If I run this command, sorry, got the syntax error there. It complains an error saying that go.mod no such file directory, because when I run this command, Docker went into that directory called foo service, which is what we define here. But the thing is, go.mod does not exist on that directory. So the context is, or this file is out of scope, okay? So what I'm gonna do here is I'm gonna correct the context. I'm gonna put dot in it. Okay, so you'll see multiple steps in here when you're building this image. There are several layers. Each of these layers, if you see there's 8 layers, defines like what happens in those layers. Like in the second layer, it changes your working directory. In this layer here, layer 7, you expose the port. This is kind of like how you would have like Docker built. Ideally, when you build an image, you want to like arrange it in a way where all the ones that will execute or arrange them as they're like, which is like the fastest. So if you know that there's some commands that will execute like really fast, put them in first as the first layers. If you have something that that will take forever, you should probably like put them on the later stage or later layers, because the way Docker builds image is that it will cache those layers so that you can build faster. So if we look at the bottom here, it says we have a foo service, which is kind of like an image. So in Docker, if you type in Docker PS, it will actually not Docker PS, but Docker images. It will list all the images that you have in your system. So the latest image that we actually built is called foo service. So that foo service, you can see that there's a tag, the latest, the ID, and then the size of it. If you look at it, it's pretty big, 870 megs. So from that image, what we can do now is we can actually run it. We can actually run that application. We can do Docker run -i. -i means open standard input, so that we can actually talk to that container, or the container can actually like talk to us. T, which is for like terminal access, and then the name of the what do you call that? Sorry, Docker run it, and then the name of the image, foo service. And then if we do that, we can see that foo service is running. And if we try to talk to it, for example, let's just do hello. We will not going to be able to connect because that container is running on its own network. If we remember, that container is in a different network. We have to find a way to be able to expose the port for that container or map that port into the Docker host so that we can actually talk to it. So we go back here and I stop this, okay? The way you do that in Docker is you do a flag called -key, which stands for port, and then you map your port. The port here, 8080, is the port for the local host to be used or mapped to the port where foo service is going to be running. So the only requirement here in this port is that 8080 has to be, you cannot change 8080 because foo service runs on 8080. If we remember looking at a code for foo service, it listens, actually 8090, sorry. It listens at 8090, okay? So the requirement here should be 8090. And in this port here, we can actually change this thing. We can just do it like 1, 2, 3, 4. And then if we go to our curl, if we do 1, 2, 3, 4, now it's working. So so the command for that, remember, or the option is that this is for the local host, this is for the service that's running, and you're mapping it. You're exposing that container to the outside world so that we can access it. So and we can run it. Okay. So the way container runs is that if there is a process, it will continue on running. If you don't have like any like processes that is running, like it's not gonna, what do you call that? It's gonna exit out, by the way. That's just how Docker works. So just to give you a demonstration on that here. So if I type in Docker PS, Docker PS lists all the containers that's running. So if we had this other foo service running before, let's just run it again. I open a terminal in here. If I type in Docker PS, I can see that my container is running, okay? If I stopped it, it's not gonna get listed out, but if I do a Docker PS-A, it will list out all the containers that I have and like what happened to them or how did they exit out. Like for example, this one, I think this one was, I killed that process. So it gave me like a exit status, okay? All right. So, so what was I gonna do? All right, so Docker will, let me find the command here real quick. Sorry. Okay, so I did say that if there's no process running, Docker would execute. And in order to demonstrate that, imagine I have this container called bash. It's just a container with just shell that you can run bash commands. And what I'm gonna do is I'm gonna make it sleep for 5 seconds. So if I do that, that means that there's a process that's running, right? So, and then the ampersand here is just, I'm just gonna like run it in the background so that I can, use the terminal again. So if I do Docker PS, it will say it's still running. It's up for 4 seconds, but right now, guess what? It's done. There's that container is not anymore running, just because there's no more process running. So once in a while, you'll when you're working with container, you'll find that what have you'll be asking yourself, hey, what happened to that containers? Yeah, there's no process that's running. It just goes away. Okay. So If I list my image again in here, okay, as you can see in here, we do have an issue. Let me just change this thing, grep service. If we look at in here, our poo service, the image that we built, it's pretty big, right? It's 816 megabytes. That's what do you call that? That's ridiculous. I mean, for that simple application, like just like an HTTP server that just returns some random text. That's pretty big. Yes, it is pretty big, and there are a lot of ways that you can actually reduce it. It really depends on first. It really depends on what type of image are you using. Like, what is your base image? This image alone is probably, I don't know, like 200 megabytes or 300 megabytes. That can be big enough. I mean, that's really huge because it has a lot of the libraries, has a lot of dependencies. So your application that you're delivering is that can be huge if you don't like minify it or in some way. There are a lot of strategies for that. Uh, you can one one uh, one pattern that you'll see out there is that they use an image called Alpine, which is kind of like it's minified image that only has all the core dependencies that you need. The problem with that is that sometimes you probably need more, and you'll end up increasing the size of the image again. There is a pattern in Docker where you can use this image as, let's just say, like a like this layer here from this prom. This is pretty much like you can just use this as a builder, and then once you're done building that binary, you want to move that binary into maybe into a different image. An example of that is the pigdb service. So let's take a look at the Docker file of the pigdb service. So if you look at this Docker file in here, um, it still does that prom layer, which is like the initial image. And then you have all your source codes and your working directory. And then the only thing different in here is that you can add some compiler option. Like, for example, like, hey, I want you to compile this project, and I just want you to like make it like a standalone. Like, you don't want any external dependencies, any libraries. You can do that for most compilers, like C++, Go, Rust. You can compile an application in a way that it can be a standalone. For programming languages like Python and Ruby, you cannot probably do that because they need the script and those are interpreted. So that can be like a drawback. So it depends on how much you can minify your application. Because, for example, like web application, you can minify your JavaScript code or your HTML code. So it really depends on that. In Docker, there's a pattern that we can use for that. It's called a scratch. So from this layer, you're gonna build that application, and once you're done, you're gonna throw that layer away. But before you do that, you're actually gonna copy the binary that you built. So if you see at line 8, we have this binary main in here. We copy that from this layer, which is what we label as builder right here. We copy that binary and we put it into this part of our layer in here. If we did it this way, your application can be minified to only contain binary. So so just to demonstrate that on how much you can actually decrease that. So what I'm gonna do is I'm gonna copy this Docker file here. All right, maybe just change some directories. FooDB, or actually this is foo service. and this is listed at 8090, right? So if we remember, it was 817 megabytes. So if I build it again, let's find that. I'm gonna name this thing as foo service with a tag called minified. All right, it's building. All right, so let's check how much do we save space in here. So this is the one that's not minified, which is 817 megs. The one that's minified is actually 741 megabytes, which is really great. So we save like almost like 810 megs. So keep it in mind, like, you can actually, when you make your Docker image, you can minify them. Be mindful about like who's going to use this image, because if I do something like a command in Docker called Docker system, the Docker system dep. Docker system dep, what it does, it calculates like how much of my hard disk is Docker is using. So I have what 277 images, and it's using like 58 gig of my hard disk. So that's pretty big enough. I mean, even my containers that are running using 6 gig, 3 gig. So if you're running Docker, using Docker, just be mindful about your hard disk, because it can get out of control. Just be careful about that, okay? So coming back to the presentation in here. By the way, in Docker, we have three ways so there's three things about like a container. You can either stop it, kill it, or remove it. The main distinction about stop and kill is that stop, Docker allows your application to exit gracefully. Typically, like maybe like 10 seconds, what I've seen in what I've experienced. But um, but kill is that, all right, you're done. Just, container, just go away. Okay. Okay. So these are some of the commands that you can actually, commonly use. I think we've seen Docker ps-a that lists all the containers. You have Docker logs. If your application is logging, you can actually have like Docker network if you want to list all the network, because you got like different types of network. Images, if you want to list all the images, and if you want to clean up, you can do RM or RMI if you want to remove images or containers. Volume prune, sometimes if you're running like a database as a container, sometimes it will fail and complain that, oh, I'm out of like disk space or memory. Sometimes, the settings, your volume settings may be like, like set into like a lower number, and that can be what do you call it? That can be problematic. Okay. System prum is you just want to remove everything. Okay. All right. So now the issue that we have in here is that another issue that we have is that what if I have a lot of containers, that can be problematic, right? Let's say like I have this container for a database, I have this container for services, it gets really complex. And Docker realized that, and that they're like, oh, no, we probably want to have an easier way to manage, what do you call that? All this container. So it's like, for the example that I gave you guys, foo service and paid DB service, I'm gonna need like at least like 2 terminals to run those containers, or maybe like one random in the background. But at some point you're gonna have to manage them, right? So what Docker did is they created Docker Compose. So what Docker Compose is, it allows you to like do a declarative way to run your services. Okay. So in Docker Compose, it starts on a Docker Compose.yaml file. Okay, so for example, in here, this line here, version, this is kind of like what the schema of what Docker Compose can use to read the properties. If you remember, I talked about networks. You can actually define a network to which all your containers can be running. So for this example, we're just gonna say, hey, when you run all these containers, I want you to put them in a network called Docker Workshop. And then the driver in here, it's called bridge. This allows all those Docker containers to communicate with a Docker host, okay? So how do we actually use this thing? So applications in Docker Compose are defined as services. So if we remember, we have two services. One service is called foo service. The other one is called bake DB service. And then we can define here how we're gonna build this service. So if we remember, foo service, we know that it needs the context of the current directory or the root of the project. And the Docker file is located at foo service Docker file, right? And then when this thing runs, we want to expose port, what do you call that? Port 8090. So we can just gonna map it similar. Let's just do 890, 890, okay? It's the same thing in here. I'm just gonna copy that. So this will be, let me see, missing a double quote. This is running at port 8080. Okay. So what I can do in here, instead of like doing the Docker run command or the Docker build command, I can just do something like Docker compose build foo service. And I don't have to give it like an option. All the options I can just put it in this Docker compose YAML file. It makes everything like easier to manage because you do it in a declarative fashion. Okay. So if I want to run the services, it's very easy. I can just do, let's say I want to build all of them first. So I do Docker compose build. It will build all those services that has those build properties. Okay. And then let's say I want to run them. For example, actually, I don't want to expose this port. So if I remove this thing, I cannot access this service. But you know what? I'm just gonna put it in there. I'm just gonna Docker compose up. So Docker compose says that, hey, you have all these services that are running. Great. So if I check in here, it says that, oh, I have this container, the big DB service, foo service. They're running right now. And if I check the network, if I do a Docker network ls, there's a network called Docker Workshop. And if we inspect that, just make this thing bigger. So we inspected the Docker Network Workshop, and it's saying that, hey, on that network, you have two containers that are running, okay? So let's try if we can access them, okay? So if I go to my curl, let's just do curl one, it's 8090 now, right? So let's see, you have Because it's running, let me just look at the foo service is running at 8090 and then 8080. Huh, that is weird. Let me try 8080. So 8080 seems to be working, but for some reason, actually 8080 seems to be working, but 8090 seems to be not working so well. I wonder what's going on in that container. Let's try it again. Let me take a look. If I think I know what's the issue is. I think the Docker file that we use got swapped. Actually, yes, it's correct right there. So we have an issue in here. So this is, you see me struggling in here. Please bear with me. Learning happens when you're struggling and making mistakes. So, oops, I need to build them first. So I'm gonna bring them down. So Docker compose down brings all the running containers. Could have probably just gave it like foo service and we'll just build a foo service. So now if I bring it up here, now I should be able to curl it, right? Think so, right? But remember,